Good afternoon or morning, everyone, depending on which time zone you're joining us from this morning. Just going to wait about 30 seconds and let the attendee list populate and make sure everyone's come in okay before we get started on today's webinar. Good stuff. Lots of people coming in, so great to see so much interest today. Today's webinar in our Critical Canadian Building Science webinar series from Building Knowledge and Enbridge Gas is sizing and selecting air source heat pumps for Canadian homes and cold climates. There's an app for that, catchphrase that always catches my attention in our digital app dominated age. We've got an hour and a half together today, so looking forward to getting the presentation delivered today to us by our presenters, who I will introduce in a moment. So as we all arrive in here, I see our attendee list is now crested the 100 mark, so we'll dive right into it today and get things going. So a quick overview of what we're going to cover today. Really, after some short introductions and a word from Enbridge, we're going to spend the bulk of the webinar on a presentation from Jérémie from the LEEP team, presenting the new tool that is the sizing and selection app, as well as taking us through a step-by-step demo featuring a case study home, all live with a little bit of switching back and forth. And Jason will be co-presenting with Jérémie today, providing some commentary and insight from an HVAC designer perspective and from an EA services perspective with some context where we have that. We will have some time for Q&A at the end of the session, and then a little bit of a wrap-up towards the hour and a half mark from myself. So starting off, we'll give a little bit of an overview of the rules of engagement for our webinar. Please, if you have questions, really encourage you to use the Q&A function in the Zoom webinar. This is the only way that we can track your questions and make sure we get to them. As much as possible, we're going to try to answer Q&A live after the presentation is done. If there's any that can be simply responded to by typing a response, then I will take care of that in the background as Jérémie and Jason are presenting. But really, we would like to engage our presenters with your questions if we can. Please don't put questions in the chat. We just have no capacity to track them there. The chat is reserved for really technical, ideally technical issues where you need support from our technical team for the webinar or other topics that are adjacent to what we're presenting in the webinar today. Please be respectful and thoughtful. This is a safe space and a sharing space, so we encourage you to engage with others in a thoughtful and respectful way. We do have some support from our BKC admin team. If you have technical concerns or general inquiries, please feel free to put those into the chat if they're not specific questions related to today's content. The webinar is being recorded and it will be available after the presentation for all attendees and registrants. There will also be a SurveyMonkey following the presentation, which is very helpful to our team at BKC and to the presenters. If you're able to take a few minutes to fill that out and provide your feedback, that helps us craft these webinars and make sure that we're addressing topics that are of interest to you so that you get the most out of these in our future endeavors. As well as the recording, links and presentation materials will be sent out following the webinar to all attendees. And if you do need closed captioning for the webinar, it is enabled. So you can enable a live transcript while we are speaking by clicking on closed captioning, which is down in the controls of the Zoom webinar between the record and reactions button at the bottom of most screens. If you're having any difficulty finding that, please reach out in the chat to our admin support team and they can help you find that link. So a couple of polls just to give us a sense of who's here. These will pop up on your screen. Please let us know where you are tuning in from. We'll give everybody about 10 seconds to click their responses and click submit. Please let us know where you're calling from. Is it morning where you are? Is it afternoon? Are you eating lunch? Are you enjoying a coffee? What is the message you're sending us? Great. So some representation. Yeah, Atlantic provinces, Ontario, British Columbia, Alberta, all well represented with a few people tuning in from the Prairie provinces in Quebec, so great to see you all here. Thank you for tuning in. And please let us know what keeps you busy. What do you do? What has brought you to this webinar in particular that makes it interesting as a subject for you? If your answer is not up on the poll, please do feel free to throw that in the chat as well. I see one French press in hand there, Jeffrey, very nice. Even some weather reports coming in from across the country, so that's always nice to see. Great, so we've got our poll results coming up. So a nice cross-section: builder, renovator, developers, engineers, construction staff, EAs, consultants, and building officials and inspectors all represented, even some sales reps. And in the chat, I see some other responses there. So thank you, everyone, for your responses. This is very interesting for us to track over time and see what markets we're reaching, what audiences we're reaching with this information. So welcome, everybody. I'm going to start off with a little bit of a message from Susan Cudahy from Enbridge, which is the sponsor for this critical building science webinar series. Susan wasn't able to be with us for today's webinar, so she asked if I could present her slides and bring this message to you. We'd like to start with a message from Susan and the Enbridge team with a traditional land acknowledgement. We would like to start today's session by acknowledging that the land on which we gather is the traditional and historical lands of the original people of Turtle Island, who have been the caretakers of these lands since time immemorial. Today, this gathering place is home to many First Nation, Métis, and Inuit peoples. Our acknowledgement of this reminds us that our great standard of living is directly related to the resources of and relationship to Indigenous people, and we have a responsibility to honor that. Susan also provided us with a little bit of a safety moment. So we like to highlight these with our partner Enbridge whenever we have a chance. Here are the steps on screen now for what to do if you observe or cause damage to a natural gas line. First step, obviously, is to stop work immediately, and secondly, to clear everyone from the area. If you can hear gas escaping or smell it, call 911 right away. And then there is an emergency gas call number for Enbridge that is on the screen there, and that's also in the chat, which you can copy and save to your phone contact in case you're working on any sites where natural gas is present and you need to remember the steps to take should an accident like this happen. And finally, one last message from Susan that she's asked me to share, so I'll just read her message. On behalf of Enbridge Gas, the team would like to thank everyone for your support with Bill 165, the Keeping Energy Costs Down Act. This legislation reinforces the critical role of natural gas in keeping energy costs down and the importance of natural gas in Ontario's measured energy transition. Your ongoing partnership has been and will continue to be essential to ensure that new homes have access to reliable, affordable energy that is available now and that will continue to be available for years to come. As Ontario continues to grow, the government's efforts to build more homes faster will make home ownership more accessible and affordable. Those of you on this call will be the ones to make this happen, and Enbridge Gas is proud to be able to support and partner with you in this effort. Please reach out to your regional residential advisor on how we can support you in reaching your business goals. So thank you, Susan, for the message and for your support for this webinar series. It's always appreciated. So quick introductions. My name is Mark Rosen. For any of you that don't know me yet, I'm the Director of Building Science with Building Knowledge Canada. And while most of our team is based in Ontario, I'm actually based on the West Coast myself. And so for me, it's coffee in hand this morning in the time zone that I'm on. I've been working as an energy advisor in this industry since about 2008. I have a background in architecture before that, and I'm pleased to be hosting today's webinar with our two excellent speakers. The first I'll introduce is Jérémie Léger from LEEP at the CanMet Energy Division of NRCan. Jérémie's been with the LEEP team for some time now, is really leading in this HVAC systems space and been doing a lot of great work with duct flow testing research and also with this app that we're going to see presented today. So welcome, Jérémie. It's great to have you here to present this to us today. And you can all read these bios in more detail when we provide the deck at the end of the session. And then from our own Building Knowledge Canada team, Jason is joining us as our HVAC technical coordinator for energy modeling services. Jason has 13 years of experience in residential HVAC design and technical support, and is working very much in this space on a daily basis, doing sizing and system design and providing great advice and support for the builder clients and other clients that we work with. So they're going to be co-presenting this app to us today. And with that, Jérémie, I would like to turn it over to you to share your screen and to take it away. I think you're still muted there, Jérémie, just so you know that. And
thank you.
There we go.
Thanks, Mark.
Take it away.
And thanks everyone for joining today and taking time to learn about this new app that we've been working on air source heat pump sizing and selection. So as Mark said, Jason and I are going to be co-presenting this one today. So let's get into it. So a quick agenda on how the deck's going to go. So we're going to first look at what is the air source heat pump sizing and selection app. We're going to frame it in new housing today, looking at some builder issues that we've heard running events from place to place around the country and talking to builders and my colleagues talking to builders and different initiatives that we do. We're going to look at how the app can assist you in selecting better system, and we're going to demo this and in the context of a case study home using the web app and seeing how we can improve our mechanical systems by having a more constructive discussion on some of the selections that we can that are available to us. Finally, we're going to review the results and outcomes of that collaborative approach and looking at different implications of sizing heat pumps different ways, and finally key takeaways for today. So what we've heard from builders, so I guess my colleagues and I, we do a lot of these forums and workshops with building industry, and there's things that come up over and over again related to mechanical systems. But rather than myself presenting back that to you, we thought for today, Jason has been working in this space for many years. So Jason, what are the builder issues that you're seeing in new housing?
Well, as we can see from the list here, we have a number of issues that we've experienced over several years. First off, being overheating during the shoulder seasons on rooms on the second floor or rooms over the garage. There's been difficulties with placement of outdoor units, either against noise complaints or even local bylaws. Space for ductwork and mechanicals in homes is getting limited. Homeowners like open concept and no bulkheads, so finding a way to integrate mechanical ductwork and plumbing is also a challenge. And of course, keeping costs low in order to remain competitive with the rest of the industry. And also, in the case of underperforming systems, builders are wanting to reduce frequent callbacks.
Thanks, Jason. So what we're going to propose today is that using the air source heat pump sizing selection app, we're going to look at some of these issues and see if we can make better selections in our mechanical system to try and resolve some of those issues on performance. We know that mechanical systems themselves don't sell home. Nobody's buying a home because there's nice shiny new ductwork inside of them. Usually the kitchen's more the wow factor for homeowners, but the outcomes can really help sell the house. So what that may be the install cost, the operating cost of your mechanical system, which relates to energy use, and some homeowners are motivated to reduce their energy use, reduce their greenhouse gas emissions, but ultimately also achieving comfort. It's the primary reason we install these systems in the first place. So making sure that we have good comfort is going to help promote that value of that mechanical system. So better systems achieving good comfort, lowering operating costs, and lowering greenhouse gas emissions will help sell new homes. So what is the air source heat pump size signal selection app? So it's a tool that allows you to select systems based on more than just lowest cost. So we're going to be going through facilitated step-by-step. It's a conversation that you're going to have. Ideally, we'd have with your HVAC trades, your designer, builder, get everybody around the table and try to resolve some challenges and communicate outcomes of selecting different systems. So we're going to be looking at an extensive library of heat pumps that we could select from. That the app is linked to the LEEP cold climate air source heat pumps database. And the app, once we use it, it gives us some outputs on energy and greenhouse gas emission savings, comparing savings and from different systems that we're interested in comparing. So we're able to communicate that performance back to the homeowners. We'll also be able to investigate controls as part of that, and looking at how different control approaches might actually influence the cost effectiveness of a different approach in terms of your operational costs. So really, the app is going to take us through a series of steps that looks at our mechanical systems, tries to address some of the builder challenges or challenges that you're facing when you're talking about your mechanical systems, and it's going to help us communicate the outcomes of those selections. It is coming out soon, so it's not yet available to the public. So we'll definitely be reaching out to all of industry once the app is finally published. So within that context, selecting heat pump is a bit, without a collaborative HVAC design, is a bit like walking into a car dealership and not specifying what you'll be using the car for, where you'll be driving it, how big is your family, if you're trying to be on a budget and not use too much fuel, what's your price point, or even what's your driving habits. And that could lead to many things, right? You could end up with this smaller car with Mr. Bean sitting on top, or maybe you can end up with this massive monster truck here that's probably a bit oversized for your needs, where all you really were looking for is kind of a nice family minivan to take your family across town. So I guess the main point here is heat pump selection is a bit the same way. If you don't know what you're looking for, if you don't know what your goals or objectives are, what challenges that you've had, you might end up with an oversized and undersized system, or a system that's not meeting your needs. So this is why a collaborative approach, one where we look at the challenges, is really going to help us select the right system. So we're going to be looking at a case study home today, going through the app. Jason, you've worked with a builder on this case study home. Do you want to introduce what we'll be looking at today?
Sure. So this is a single-story net zero ready build. I believe it's being built in London. Just to take you through the specifications real quick. So this was a house where their air tightness they were aiming for was at least 1.5 or better. So that's what the heat loss and gain calculations took into account. We used R60 insulation, or they used R60 insulation in the attic, R14 plus R10 continuous framed exterior walls above grade, and then R14 plus 10 continuous insulation below grade on a concrete wall with R10 under the concrete slab. They used triple glazed low E windows with a U value of 1.2 and a solar heat gain coefficient of 0.22, covering about 16% of the wall area, as well as a 75% efficient HRV. And as you can see up near the top are where our heating and cooling loads came in. So our heating load came to about 23,000 BTUs per hour, and cooling came in at about 17,000 BTUs per hour.
Great. So we're going to be doing a demo now on this home. So we're going to be using the web application, and it's going to be, the bigger part of today is going to be walking through the app. But we need a few things before we get into the app. We'll first need a whole home design heating and cooling load for the home. So an F280 calculation as required by the building code. We're going to need to be ready to discuss past issues and goals for the project. So whether that's the builder or the architect or whoever knows about the past projects, issues that they've been having, so that we're better able to discuss best fit solutions going forward using the app. Also understanding market challenges and what's motivating sales. So if we're looking at a certain demographic that's looking at reducing their greenhouse gas emissions, that might influence our system selection, versus they're looking at lowering their operating costs, that might change a bit how we want to position things using the web application. So let's get into it. And this is the web application. When you first log in, so it's going to be, you're going to have a project management page where all your projects are listed, and you're able to copy and delete projects. And we've set one up for today's session. So let's get into the one that we've set up. So as it's loading, when we use the app, it's going to be a step-by-step approach. So we're going to go from step 1 to step 13 in this case. And that's how we'll be using the web app. So step 1 is mostly about identifying what type of housing that we're dealing with. So the app covers more than just new housing. It covers existing homes as well, and from light to deeper retrofits. It is specific to your mechanical system, and it looks specifically at heat pumps. And depending if you're in new housing or in existing housing, the steps that you're going to see are going to be a bit different. So the app adjusts to the situation that you're in. And so you really have in context types of steps that you're walking through as you're going through the app. As Jason mentioned, this is a house that's located in London, Ontario, a bungalow, which means that it has 2 levels, so a basement and a main floor. As part of the first step, we'd like to start about understanding the issues, start about looking at what's motivating this new build, and what are the goals for this mechanical system. So Jason, you had a conversation with the builder. What were those challenges and goals that the builder was dealing with?
They wanted to meet the objections that we brought up in the earlier slide. So if you go down to these options, you'll see they're described in a little bit more detail. So they were concerned about energy efficiency, which tied into their desire to achieve net zero ready. They were concerned about lower upfront costs and operational costs. They wanted to be environmentally friendly, so they wanted to get an idea of how to reduce their greenhouse gas emissions. They wanted a quiet outdoor unit, which was important to them, being built in a suburb. And they did want to keep the interior bulkheading to a minimum. So they wanted a little extra thought put into how to route ductwork and other mechanicals. And of course, they had a finished basement in this house, so we all had to make it work with a finished basement.
Great. So what's happening in the background when we're making these selections is that the app is gonna in the future steps make some recommendations about which choice might be more appropriate based on these selections. It's going to try to guide you towards a certain step and just help that conversation as it moves along with a designer or your HVAC contractor using the app. So let's go to step 2. And step 2, the first steps are fairly high level. So we're looking at air source heat pump unit configuration. So are we centrally ducted? Are we ductless? What was the selection for the builder in this case, Jason, and why?
They went with centrally ducted. I think part of it was they wanted to keep with, excuse me, they wanted to keep with what had been installed in their previous homes, but they were still more concerned about even air distribution throughout the home, as opposed to spot heating and cooling with mini splits.
Great. So that completes our second step, and there's a little marker here. We can mark if the step is complete or not. So we've marked that step as complete. The next step is around the sizing approach and capacity requirements of the heat pump. For those who are familiar with the Enercan air source heat pump sizing selection toolkit, so just is a PDF document that you can walk through. It gives 4 options in there to look at your sizing of your heat pump, from emphasis on cooling all the way to heat pump sole source heating. What was selected in this context, Jason, and what's your sizing approach that you took on this house?
So this house was meant to be a dual fuel system. That was a request from the builder. So there will be natural gas supplemental heat, but they wanted to use an air source heat pump as well, and they wanted to be able to use it as much as possible, or see how much of the heating load the heat pump could handle before requiring switching over to backup heat. So we chose option 3C, which is going to show us the emphasis on heating. And again, that will allow us to see how much of the heating load can be handled by the heat pump before requiring gas.
Great. So moving on to step 4. So step 4 is where we start getting into if we have what type of supply that we're going to have. Are we going to have low wall supplies or high wall supplies? And if we're not sure what these are, as you've seen on all of these steps, there's a more information button, and we can click on that more information button. It gives us kind of an outline of what this option is and what might be the advantages or disadvantages of each option. So in this case, Jason, what was the selected approach, and why did you move towards that approach?
So at the builder's request, we designed this house with central high wall supply diffusers. This was done to keep floor registers out of the equation, so there would be no chance of anything being covered by furniture, but 2, also to have diffusion into the living space without blowing air onto the occupants directly.
Great. So moving on to step 5 then, now we're getting into duct sizing. So you've probably heard of low velocity systems, medium velocity systems, high velocity systems as different types of mechanical equipment. So those are selections that we could make. On the bottom here, as I mentioned previously, when you make selections on the app tries to guide you towards certain approaches. So for example, in this case, picking the medium or high velocity might reduce your requirement for bulkheads, for example. Jason, what was the selected type of ducts for this house, and why did you choose that?
So we chose medium velocity ducting. Again, at the builder's request, we wanted to try and reduce number and size of bulkheads throughout the home, especially running throughout the finished basement. So we were able to use a slightly higher static pressure, which gave us a bit more velocity, which enabled us to use somewhat smaller ductwork while still remaining within the velocity limits published by the duct design manual.
Great. So we've selected medium velocity ducting here in the web application. And then we're gonna keep moving along. The next step that's presented, again, we haven't touched heat pumps yet. We're still talking about ductwork and ductwork approaches. Is are we going to zone the supply of ducts? So there's different zoning approaches that are available to us. Could you walk us through, Jason, some of those zoning approaches and which one was selected for this home and why?
So we have the three options here. So a single zone system is exactly what it sounds like. Each area of the house is subject to one supply temperature from the furnace or heat pump in this case, and there's strictly one thermostat to control it. 6B, where we have one zone per floor, allows each floor to be kept at a different temperature than the others for occupant comfort, or for for occupant comfort. And then 6C is other approaches, which allows us to zone the house according to specific customer requests. So like the image is showing here, a loft might be a zone, and then the rest of the house might be on one or two zones, or a certain wing of the house might be on one zone and other sections of the house would be on another. So in this case, because it was a single story bungalow, and to keep the system simplified, the builder requested a single zone system.
Great. So now we're going to be looking, so we looked at the supply side, now we're looking at the return air side. So there's two different approaches that could be taken, some traditional return air systems or some simplified return air systems. Could you briefly explain the difference between them, Jason, and just what was selected in your particular case?
So a traditional return system is where we use stud and joist bays as return air pathways to get returns from bedrooms and living areas back down to the main return trunk and to the furnace or air handler in the basement. A simplified return is where we do the same thing, but instead of getting returns from each bedroom, we might get one per floor, and then one for a master bedroom and one out of a room over a garage or with a cold floor. In this case, we kind of did a bit of both. We were able to, with the architecture of the home, we were able to keep the return trunk fairly short while still being able to pick up returns from each bedroom on the main floor and the living spaces from the basement and main.
Great. And in your experience, have you seen some advantages to just having that one return per floor ducted? Has it reduced costs in some cases?
It can. It is a much simpler system, less prone to leakage. As I'm sure a lot of us know, stud and joist bays do tend to leak. So having many returns done in such a way is a lot leakier than having one or two simplified returns. So
great. So the next piece, the final piece, I would say, even on ducting, that's included. So step 8, we're looking at duct sealing. Would you mind just going through what these options are, Jason, and why would you choose kind of a better sealed ductwork versus a code minimum sealed ductwork?
Well, again, ductwork, even well-assembled ductwork, still tends to leak at each seam and transverse joint. So to ensure that the airflow is actually getting to each room without being lost to a wall cavity or to any other space in the home, we do recommend duct sealing either with tape or mastic, or even with AeroSeal in some cases, to ensure that the ducts leak as little as possible. So the three options that you're seeing here, option A is base level code minimum duct sealing, which is defined as a SMACNA level C duct seal, which just means duct sealing should be done on the trunks and branches, at the transverse joints, and around takeoffs and around boot fittings, and at the plenum, but only on the supply side. Option B is going to be sealing to Energy Star requirements, which is the same as A, but then the return air drop and about the first meter of the return air trunk are also sealed to smack in a Class C, as done with the supply. Then option C, again, is the same as option B, but now it is subject to verification testing. So the duct leakage would actually be measured in this case, and if there's a duct leakage target that's trying to be met, then the ducts would be sealed until that target is met through repeat testing.
Great. So we can capture some information on top of this. So maybe there's some specific items that we want to make sure that we communicate to the contractor as we go on site. And the app allows us to track comments as to either why we're making certain selections and to specific items that we might want to note. So maybe we want to note that sealing the return ducts will help. So we can put a note in here, and we can save those notes. And on each step, you can do this. So you see here, I've added a note, and that's another feature of the app that as we walk through, we can capture some key points that got brought up on each step. Moving along to step 9, we're looking at the heating and cooling load according to CSA F280. If you're not aware, CSA F280 is a code requirement in new housing. It certainly is best practice in retrofits to get the heating and cooling loads before we replace equipment. So because we're new housing, the app doesn't give us any other option but to put a CSA F280 heat loss, heat gain. And it's going to use that in the back end to make some calculations on energy, greenhouse gas emissions, as well as annual heating costs. So in this case, Jason, you completed an F280 calculation. What were the results?
Yeah, they're as you see there. So 23,372 for heating and 17,334 for cooling.
Great. And you completed a room by room analysis, no? In your case,
correct.
So
Yep.
we're just requiring the whole home here, but a room by room analysis is definitely what's needed to do the HVAC design. So step 10, we're looking at heat pump selections. So here is probably one of the most interesting step where we actually get to select some heat pumps. So a big thing about the app is we're able to compare different systems against each other on the metrics of greenhouse gas emissions, energy, and cost. And what we've done here is we've linked the app to the NEEP cold climate air source heat pump database, and we're able to go and select any of the brands that are available in the NEEP database and all the models that are available there. So we can type in an HRII number, maybe have a model or unit number. We can filter by capacity, and all that's needed is we just click the compare button and it adds a heat pump on top here. So Jason, you've gone through the exercise with the builder. You've selected some heat pumps here. What are these choices, and what was the builder looking at comparing here?
Well, the builder, as I said earlier, the builder was looking at a dual fuel arrangement with an air source heat pump. They also requested a cold climate air source heat pump. So that informed some of my choices here. So heat pump numbers 1 and 4 are specifically dual fuel arrangements. So heat pump number 1 is a heat pump. It's a cold climate heat pump with a third-party ADP coil. It is AHRI certified as a coil only, so it can be put on any air handler as long as that air handler meets the airflow requirements from the manufacturer. Heat pump number 4 is also a coil only system from Mitsubishi. So that was just put in there to compare two different coil only air source heat pump combinations. And then numbers 2 and 3 are all electric equipment. So that would be the heat pump with an indoor air handler. Again, just put in there for comparison's sake, just to show if the builder did want to go to an all electric package as opposed to dual fuel, how that would look and what that would cost as far as operational costs, as far as operation costs are concerned.
Great. So those are the heat pumps that we're looking to compare. So we've defined the heat pumps there, but the NEEP database doesn't have information on what the AFUE of the furnace is and things like that. So we also needed to, we have to redefine that in here. So we're able to select electric backup or a furnace backup. If we're on a furnace backup, we could pick gas, propane, or oil as kind of that backup system that's included as features in the app, and then we can place what the AFUE of that system is and its capacity if it's in a new or existing condition. Obviously, new housing, we're going to be mostly new and probably gas, unless we're not close to the gas network. Otherwise, propane might be more the hybrid solution there. So we've, like Jason said, the first option we've selected was a furnace. The next one we looked at was an all-electric system. We have 2 all-electric systems. Here we can add the backup capacity of that electric system. So heat pump number 3 being a smaller heat pump that can't meet the full load. And heat pump number 4 here, we've modeled as 96% AFUE, 40,000 BTUs per hour of capacity. So once we've done that, we've effectively defined the 4 systems. So now we're going to get into utility rates and controls. So in this case, we're able to, if we're in Ontario, we can do time of use. We can tell the app what the on-peak, mid-peak, and off-peak costs. If you're on a single rate, we can define it that way as well, just by going down the drop down and just clicking fixed. We can insert our cost of gas, and one important thing here is we're looking for the total electricity and gas price. So it's the price that includes the taxes, the transport fee, the commodity fee, all the additional fees per kilowatt hour or per meter cube, depending on electricity or gas. If you're looking on how can I calculate this, there's some instructions, some examples on how to do that on the bottom as well. So once we've defined our utility rates, the app is now asking us to define what control strategies each heat pump is going to take. In this case, the first one was a hybrid system, so it's giving us 4 options. The 4 options are the backup only below the thermal balance point. So the thermal balance point, for those who are not familiar with the terminology, it's when the heat pump can no longer keep up with the heating load of the house. So it can't heat the house anymore. It can provide some heat, but not enough heat to heat the house. So in this case, and it's often the case that heat pumps are set up with a straight cutoff. So at a certain temperature, we go full backup and we no longer use the heat pump. Of course, you could probably imagine we're going to get less usage of the heat pump with a strategy like this. There's some a similar approach. We could, instead of cutting it off at the thermal balance point, we could cut it off at an economic cutoff temperature. So a temperature at which, based on the COP of the heat pump, maybe it's better to run electricity above that temperature and it's cheaper to run gas below that temperature. So the app will calculate what the average point is and pick that single point economic cutoff temperature. We could also do it on an hourly schedule economic temperature. So there are thermostats that are able to do that out there in the market today, where hour by hour, we check the electricity price, we check the gas price, we check depending on the temperature, what the COP of the heat pump is, and we make a selection whether to run gas or electric. Those, because gas is generally cheaper, they tend to favor a bit more the backup system than the heat pump system. Finally, if we really want to maximize our heat pump usage, option 11D is we're going to be looking at running our heat pump and backup system below that balance temperature. So switching on the heat pump first, and then once we realize it can't keep up, either the temperature dropped too much or there's a certain amount of time that elapsed, maybe 10-15 minutes, then the gas system would kick in, the heat pump would turn off, because we generally can't have both running at the same time in common configurations. On the all-electric side, we have less options. We could operate our all-electric system like that backup approach that first turns on the heat pump, then the electric. But the most common approach would be to run it simultaneously, so the air source heat pump and backup runs at the same time, and that's how most all-electric systems are set up like this. So we've gone ahead and made some selections on kind of the backup systems, and we've essentially tried to maximize their heat pump usage in this case. Looking at controls, we can also talk about dehumidification strategies. Some thermostats will not measure humidity or not have some kind of dehumidification control, while some will. So making that informed choice of what thermostat you're buying and does it have some kind of dehumidification strategy might be important. So especially for those summer months where it's a bit more humid, and many areas in the country would require some form of dehumidification. So generally what happens here is it allows your heat pump to run on low for longer periods of time and extract more water out of the air. Finally, we land on step 13, which is our final step for the app, where we present greenhouse gas emissions, heating costs, and heating energy consumption for our system. Jason, you've worked with builders. Can you maybe walk through some of these metrics and how these could be used as part of a motivation to pick one system versus another?
Sure. So with greenhouse gas emissions, there are an increasing number of builders who are more aware of their carbon emissions and CO2 emissions. So for those builders that want to reduce that footprint, the app does give an estimate, a rough estimate on annual greenhouse gas emissions for each selected heat pump, depending on how long they run and how much backup they would have to use. The heating cost is for the price sensitive homeowner if they're very sensitive on operational cost. This column represents an estimate of how much it would cost to heat for the year, or for the heating season, I should say. And then on the right-hand side, we have energy consumption in gigajoules, and this would be helpful for energy advisors or energy advisors putting together energy modeling to try and hit an energy efficiency target like Energy Star or Net Zero. So this could help a builder or contractor select a heat pump that fits in with that goal.
Great. And to contextualize, this is only for looking at the heating consumption in the heating season. So the app doesn't consider the summer season in terms of energy, and so we're really looking at heating costs in terms of how things are calculated in the back end. So finally, there's some other features in the app that we haven't kind of gone through. So once we've gone through the 13 steps, we can go to the checklist. And the checklist is really just there as a summary of all the selections that we've made so we can go back, review it, print it out, share it with the team so that everybody's on board, everybody knows what type of system we're installing here and what type of approach we're going to take in terms of the design. To further support, the app has best practice videos as well. So some case studies that that builders have gone through, or different, whether it's retrofit or new housing, and looking at different ways of implementing heat pumps as well. So encourage users to go and take a look at that as well. So let's recap. What could all this mean? So we started off with a base case where we had a system that had a 40,000 BTUs per hour, 96% AFUE furnace, which would have been the common furnace being installed, probably the smallest furnace that could be found for this home. Still a bit oversized because the heating load was 23,000 BTUs per hour. But unless you go with specific brands, that's probably the smallest model you'll find. We look at obviously the operating cost of that system on that house was $683 for the heating season, and we're emitting 2.9 tons of CO2 over the year just for the heating season. A common way of sizing heat pumps is to size to the cooling load. So seeing the heat pump more as a cooling device rather than a heating device. So we've taken a look at what if we size that system that way. So this is a 1.5 ton system. In this case, that would be selected, and we'd get roughly 60% energy save from just on the heating side from this system. So not too bad already, just starting off with a heat pump that's undersized for the heating load. The operating cost of that heat pump would be $864 in this case. We're running into colder temperatures where cost of electricity versus gas, but that's the difference that we end up making. But we do reduce greenhouse gas emissions by quite a bit, going down to 0.44 tons of CO2. And I guess the main point that I wanted to point out here is the importance of controls. So at some point, we talked about the thermal balance point and how it's the point where the heat pump can no longer keep up. And the common way of controlling systems is that at that point, contractors generally set the thermostat so that it goes on gas fully. So it doesn't run the heat pump below that point. So if we did that, the heat pump would only cover 65% of the heating season. Now, if we let the heat pump run for 15 minutes before starting up that gas furnace, we could probably cover up close to 94% of the heating season. So that's a 29% difference in heat pump usage just from selecting one control approach versus another. So quite impactful, making sure you get your controls right. If we look at a second scenario, and we now size the system, so a hybrid system again, to the full load. So that's that first system that we looked at. In this case, it was a different system. The COPs are different. Ends up that the energy save is actually less, just because the COP was likely lower than that first system. We increased the operating costs where the heat pump's operating at even colder temperatures, covering a bigger portion of the load at cold temperatures, where the COP tends to be lower. But we do reduce our CO2 emissions by a bit more. And obviously in this case, the heat pump can meet the full load. So whether we control it by balance point or other methods, we're covering 100% of the load. So the heat pump should be turning on 100% of the time. As scenario 3, if we looked at, Jason explained it, we had all electric systems that we would cover as well. So as an alternative, going back to a similar system as system 1, so with better COPs, and a 2-ton system, we're now saving a bit more energy. So we're at 65% energy saved. But the operating costs would be a bit lower than that scenario 2 heat pump, because we have a slightly better heat pump here, and we'd lower our tons of our GHG emissions. So essentially, higher efficiency equipment can matter in this case. It's just over $100 in operating costs a year for picking that slightly better system. Finally, the importance of improving your envelope. We started off with a net zero case. It was already a pretty good envelope, but I think it warrants still making the point here, because not every home starts at net zero targets. So let's say we reduce the load by 25% and pick that all electric case. So we pick that 1.5 ton system that in this case going to be able to meet the full load. So we're now able to meet the full load with a smaller heat pump because we've reduced our load. So now we're saving 74% over that base case in terms of energy saved. Our cost of energy is actually lower than that base case again, and that's probably our lowest GHG emissions per year. So I guess the main point here is reducing your loads is really going to get you into a smaller system, and it's going to be able to cover a larger portion of your load. And looking at the ductwork, so Jason, do you want to walk us through some of the duct upgrades that we did, and what are the implications? How did we improve the house by making those selections?
So we reduced the need for some bulkheads, not all though, by going to high velocity and smaller ductwork. Our simplified return, and also the smaller ducts and higher velocity, and the simplified return all kind of contributed to a simplified install and a reduction in cost. And then the combination of our high wall diffusers and air sealing, or duct sealing, I should say, can go a long way towards improving comfort. And for that, we'll just have to see once the homeowners are in there.
Great. So let's recap with key takeaways. So essentially, Enercan Zero Source Heat Pump Sizing and Selection app, it helps provide data to support you in selecting your mechanical systems. You can have kind of a conversation around your ductwork approaches that you can take, design approaches that you can take, and then pair that with selecting the best fit heat pump that achieves the targets that you want, whether that's on greenhouse gas emissions, energy, or operational costs. And better data is going to lead to more effective communication on performance, and then careful selection is going to lead through better performance, and better performance generally leads to fewer callbacks with the homeowner, which in turn saves costs as well. Point 2, using F280 is best practice for sizing. It's actually code in new housing. So definitely encouraging all to do load calculations. I know it's more popular in some areas than others, but it is definitely the right way to start off designing your mechanical system. And finally, choosing the right control approach can significantly increase the portion of your heating season covered by the heat pump. So just because you've spec'd a really good heat pump, it doesn't necessarily mean that you're going to get the best outcome out of it unless you control it properly. So be very choosy about your control options and make sure that it aligns with your objectives that you're trying to achieve. And with that, I think we have a few minutes to take questions.
That's great. Thank you very much, both of you. And it's a good thing we've got a few minutes for questions because we have quite a few that have come in. So thank you, everyone, for submitting those. We've got plenty of questions to get through, and I'm going to try my best to pose them live so that we can get live answers as we go through these. I'm going to start with the one that we anticipated first and foremost that's come up a few times. When can we get access to this online tool?
Yeah, so we're hoping that it'll be published by the end of the summer. So that's our goal. It will be it should be by the end of the summer. So we don't have an exact date, but as soon as it is, we will be sharing with all of our networks.
And a follow-up similar question, someone asked if this web app is envisioned to be a complete alternative or replacement, if you will, for the existing sizing and selection toolkit that you've developed. Does it do the same thing effectively all in one place?
So definitely not a replacement. So the Excel tool is actually undergoing some upgrades right now. Definitely going to have more of the latest features as we're trialing out new things. There are some items in the Excel tool that it's maybe you can see the Excel tool as maybe more of an advanced tool where the web app is one that facilitates the mass market a bit better. So we're able to use it. The Excel tool is a bit harder to use. Not everybody's familiar with Excel, whereas the web app is a bit more friendly in terms of its user interface as well. So there are some differences in terms of the outputs that you can get as well. There's a bit more information that's outputted, more data on the Excel tool that's presented in the app. So both will always be there is the intent.
Okay, great. I think one thing I wanted to highlight as well, one of your key takeaways, I really liked the language that you put in key takeaway number one. I think was something along the lines of this app is going to provide data to support the selection of your heating equipment. And just as a question for both of you, I wonder if you could speak for a moment about, where does this app end and HVAC design take over? How do you make that distinction between something that's going to help you confirm a selection that you're considering versus a completely sort of adjacent discipline of HVAC design and the expertise that's required for the F280 calculation, for the duct selection and layout, et cetera, that may be outside the purview of what this app is really doing for you, if you will?
Well, the app is really just helping you select equipment. An HVAC designer is still going to want to look at the input and out, or the output of that equipment at certain temperatures. The colder it gets outside, the lower the capacity becomes for an air source heat pump. So that's going to have to be looked at. And then there could very well be a matter of going back to the drawing board, because maybe one selection from the heat pump selection tool doesn't bear out as far as HVAC design is concerned. So there may be a matter of going back, looking at a few more, maybe narrowing down choices, looking for different outputs or different efficiencies to find one that works for the project at hand. And then once the equipment is confirmed, or once the selection is confirmed, then HVAC design can begin properly.
Yeah, definitely agree with Jason on that one. I think the app is more there to support that upfront collaborative approach that would happen before you get into detailed design. So you want to kind of confirm high-level design directions before you go and make out all the details. So it's not going to be replacing any HVAC design for sure.
Mm-hmm. Yeah, and along those lines, one of the questions that came in was about the product selections that you showed today in the live demo. Can you speak for a minute to the process used to select those products in the app? I'm assuming, I think correctly, that the app does not recommend products to you. It's all about selecting the ones that you would like to evaluate against your assumptions and your inputs.
Right.
Exactly. Yeah. Go ahead,
So
Jason.
yeah. Okay, sorry, Jeremy. Part of that equipment selection was directed by the builder. They had a couple of models in mind that they wanted to compare. So that's where those selections came in. And then I, kind of working from their request, I went ahead and kind of took it upon myself to compare different models from the same manufacturer, just to give them a more complete picture.
Okay, great. I'm going to try and filter through. We've got about 30 questions, but I'm going to try to start with the ones that pertain to the app specifically, as opposed to heat pump, technical questions or HVAC design more broadly, if I can. Jeffrey asked, what did the videos show? I think in a lot of the screens that you stepped through, sometimes there was a more information button, sometimes there was a show video button. Can you speak to those videos a little bit?
Yeah, so the videos are there to similarly to the more info. They're case study videos where specific steps have been applied in industry. So just kind of showcasing the value of that specific selection. So it just kind of talks through that selection and the benefits of that selection applied to a real case study that happened that we had videos for. So as we build out more videos, we could see kind of populating more of the steps, but where we had videos, we included it into the app.
Okay, great. The next question was, is there a place in the app to enter F280 design heating and cooling temperatures? Perhaps that wasn't apparent.
I'm going to say, I can try and tackle that.
Yeah.
If they're talking about outdoor design heating and cooling temperatures, I'll say no, because those are tied to the location selection. So when you select province and city, in the back end, they are tied to those locations. As far as indoor design temperatures, I'm also going to say no, because those are assumed to be building code temperatures, which I believe is 72 Fahrenheit or 22 Celsius for heating, and then 75 Fahrenheit or 24 Celsius for cooling. So long story short, no, you can't change it.
Right. So the inputs are really, they're governed by where you're modeling, your selection of location, as you mentioned, and the regulating codes that are inputting that as well. Right. On the subject of inputs and outputs like that, we talked about F280, the importance of F280. Sort of two-part question for that. The first is just about the calculation of the loads of the F280 itself. I think this is maybe a bit generic as a question, but the question is, can you recommend some good F280 load calc software? And maybe we can caveat that a little bit by, asking who should be doing and using that software to come up with that F280 calculation in the first place.
So software is only as good as the user. So that really any kind of a design software, HVAC calculation software, should only be used by an HVAC designer who is trained either under HRAI or under any other discipline that's around, like TECA, or in the States under Manual J or Manual D, because it is a fairly straightforward process, but it is also a very easily manipulated, not manipulated, but it's an easy to kind of go down the wrong path when doing a design. And then if you don't realize you've done that, then you don't realize that your end result is not reflective of reality. Saying that F280 is built in a way to be conservative with its results. So a properly trained HVAC designer will know this and will be able to recognize if their results are realistic or not.
And then Jeremy, did you want to add to that?
I was just going to add, so
Please.
the other part of the question touched on software and where can we get good software on this. And HVAC Designers of Canada have been doing some great work on this, where they've built a listing of software that's been proven to follow F280. So F280, as of a year ago, now has an extra clause that looks at software testing and verifying that software actually follows the methodology. So There's 7 software that have passed so far. Some are private companies that for internal use, but there are some that are for public distribution, that commercially available software. So I encourage people to use that listing as kind of approved software that does F280 calculation. I don't know if it's appropriate to put a link to the site or not, Mark, but I can certainly.
Yeah, if you have a link and you want to drop it in the chat, I think that would be great. And I think as well, it's important to highlight, just on this tangent a little bit. Some software does both room by room and whole house. Some only does whole house block load calculation, and I think it's important, as Jason you highlighted, that the person using the software understands the limitations and applications of each. And is trained to use them properly, because this really, it's a foundational input to this tool, isn't it? That you have the right loads up front, otherwise you're measuring against perhaps an incorrect baseline otherwise.
Mark, I just had a quick question. I did see a question that came in the chat. Someone did ask, can HOT 2000 design heating and cooling loads be used? And then what would be the accuracy limitation? I saw that it was marked as answered, but I don't know. I don't think we answered it yet. So I just wanted to kind of double back on that.
Jump in. Yeah.
Forgotten.
Yeah. Great.
Okay. So short answer to that is yes and no. The longer answer is no. The HOT 2000 design heating and cooling loads can't be, well, they can be used in the app, but they are not an accurate representation. They're not as accurate as an F280 calculation, so they wouldn't be used as a basis for sizing equipment. With the HOT 2000 numbers, they tend to be a little rougher, especially on the cooling end. HOT 2000 notoriously underreports cooling loads. So, saying that, a company called VoltaSnap has developed their own software. I don't know how available it is, but they have developed their own software that takes a HOT 2000 file and creates an F280 load calculation from it using the same inputs. Those numbers are much more accurate. I can speak to that from personal experience, and I would trust those over the straight HOT 2000 outputs. Right. So again, to get a rough idea, you could use the HOT 2000 numbers, but it wouldn't be a great idea.
Mm-hmm. And to the list that you just posted, Jeremy, I believe VoltaSnap is on that approved list in HVAC DC, has done the assessment there. So last question on the F280 subject. I just wanted to look at the case study that you presented today and ask, we saw that this was a new home, so the only option given for the sizing calculation was an F280 calculation. Jeremy, it seemed like you hinted that in an existing home scenario, there may be other options in the app to select there. Can you touch on that for a second?
Yeah, so F280 is definitely the preferred route, always. Of course, HOT 2000 is sitting out there, and I think many contractors today are using the HOT 2000 numbers to size systems in retrofits because it's available. And a better route would be, as Jason said, to go and use a software like VoltaSnap to make sure that you actually get that accurate cooling load in particular. So those are options that are listed when you're in retrofits, because there's no codes currently. So that would be kind of the second choice that's most popular. And then I guess the least preferred approach, sizing to existing equipment, right? If you have a certain size equipment, it works, it's likely going to work again if you install that same size equipment. That said, most equipments out there on the heating side are going to be 2 to 3 times oversized in general is what we've seen. And on the cooling side, it's generally better because you'll see comfort issues if it's not sized properly, but you could still be off a bit, and you might be missing some opportunities there by not doing the analysis.
Right. Great. There were a couple questions about some of the costs and calculations that go into the operation costs in the app. A couple questions about the utility rates and whether or not the utility rates include transmission, distribution charges, delivery, etc. Is there a separate way to input those, or are those rolled into the numbers that you can type in as you showed?
Definitely want to
So
roll. Yeah, go ahead, Jason.
yeah, so no, go ahead, Jeremy.
You want to roll them in, is the point, but you want to only roll those in that are per kilowatt hour per meter cube. So those fixed costs, they're going to be fixed costs. Doesn't matter how much energy you're using. So don't include those. Only include the ones that are variable for how much usage you're getting.
Yeah. So
But
in
no fixed
in the
fees or so account fees, etc., are not
No.
accounted for in those cases.
Yeah.
Right.
So in
and-
the air source heat pump toolkit that comes with the Excel tool, there is instruction on how to calculate your costs based on a bill or based on a sample bill. Actually, I believe the sample bill is also in the app as well. But yes, you are deducting your fixed costs, but you are including any delivery costs associated with the amount of electricity or gas that you're using. You're also including taxes. And in Ontario's case, we can also include the Ontario Energy Rebate for as long as it exists. So those prices that we used today includes all that, but again, we've backed out the fixed costs.
Right. And along the same lines, a question about the all-electric scenarios. Is there any functionality in the app to assign savings for not having the gas connection at all? I'm assuming it's a similar answer. That's an outside calculation.
So not currently, but that could be a feature that could be added in a later version.
And I think that a bit of a more of a recommendation than a question, but one of the participants asked, is it possible, if you're a repeat user of this, that you enter your region and you have these values default every time you add a new piece of equipment for utility rates, etc.?
So currently, no. There is an option to copy projects though, which might kind of do the same thing if you're generally doing the same design approaches and just want to walk through what those design approaches are. And then, so if you copy a project over, you'll be able to just kind of update your loads, maybe change a few of your heat pump selections, and all the information should copy over from project to project, so you won't have to reinitiate your location and things like that.
Okay. Oh yeah, well, we've got about 7 or 8 minutes left for questions, so I'm going to move into a bit of a rapid fire mode and just go through them step by step. So point form answers if you can, and we'll take these as we get them. High level question: are production home builders switching to air source heat pumps instead of AC? And is this a common trend we're seeing today?
I'd say so. Yeah, it's a common trend. The builders I work with, they're going with heat pumps. I couldn't tell you percentage wise. That is, I don't want to risk saying anything percentage wise, but it is definitely the majority.
Great. Next up, is it normal for air source heat pumps to get hot or very warm to the touch? Maybe outside of the app, but in general terms.
Unless you're
Not
touching the
specific
coil.
enough.
Yeah, I don't think you'll.
Are they talking about the ductwork, the coil, the outdoor unit?
Yeah, maybe some clarification is required for that question, but
yeah, refrigerants lines
depends on your pain tolerance.
Cold, but yeah.
There you go. A question about zoning, and actually I had a follow-up question to this one, but question about cost. Is it more expensive to have multiple zones compared to a single zone? Can you give a relative increase in cost?
Short answer, yes. As far as increase, it depends on the manufacturer of the zoning equipment. Some furnace and heat pump manufacturers will supply their own zone controls and zoning hardware. Other times you'd have to buy zoning hardware and controls from a third-party vendor. So again, it depends on the equipment package that's selected. So that would probably be a conversation to have with your contractor.
Yeah.
But yes, in general, it will cost more to do multiple zones versus one.
Yeah. It might also differentiate the zone ready ductwork versus the one with you actually put in the automated dampers. Because zone ready, you might be able to get cost neutral with doing simplified ductwork approaches, zone ready supply. Then that zoning package might be an upgrade that you can offer at an initial cost, but then you have your duct design that's already zoned and you can do with manual dampers some pretty good stuff there.
In the app itself, Jérémie, how does your selection of your zoning configuration impact the outputs that the app is giving you?
So if we would have selected a zoning approach, it would have then asked us what kind of if we're going to be zone ready or what kind of zone package we would have included. So there's an extra step that's included there if we select zoning.
Right. Okay. In general, a general question about heat pumps: do we have to have electric or gas heating backup, or is it possible to use only a heat pump as a designed system?
It's possible to use only a heat pump, but it should be on a house, or it should be in a house that is already taking steps for energy savings. So something like a net zero ready, where the heating and cooling loads are relatively low compared to a code built house of the same size. So, for example, let's say you've got a house that's got a heating load of 19,000 BTUs. Theoretically, you could have a 24,000 BTU heat pump, a cold climate heat pump, I should say, that can handle that heating load at design conditions without requiring backup heat or backup electric heat. Yes, that is doable. But to this person's other part of their question, oversizing the heat pump generally is not a great idea, because one, you'll have to upsize the ductwork to match, which will add to the cost of the entire job. And two, you're also increasing the cooling capacity. So in effect, you're oversizing the cooling capacity of the house, of the heat pump for the house. So that could lead to short cycling in the summer, as well as a lack of dehumidification in the summer, which could lead to moisture issues.
Next question is the best way to access the LEEP database. Is there a recommended link that either of you might be able to share either in the follow-up or in the chat? I'm going to suggest if we don't get that in the chat, maybe we can include that with the materials when we send them out to applicants. So thank you for that. GHG emissions. Will the house have generation to be net zero energy and GHG? Would emissions for all electric then be zero? And I'll take a stab at this one just in the interest of time. You may be able, from a net zero net calculation, be able to demonstrate that you're producing energy to offset what you're using. It's hard to say broadly that adding solar generation is going to mean zero greenhouse gas emissions produced on site, because of the balance of production and consumption, how that works out, whether you're on net metering or battery backup. More complex than the straight math proposed. I think we'll leave it at that for now. I wanted to get to this next question because I think this is important. Question broadly is about third-party thermostats for controlling these systems. You touched on this a little bit in terms of zoning already, Jason, but would you agree with the statement that I'll propose to you, and that wherever possible, because of the complexity of controls, that the manufacturer's thermostat is typically a good place to start as opposed to third-party nests, etc.?
I would agree with that.
Yeah, we've had some discussion in seminars in the past, I think, where we've categorize Nest thermostats and other good thermostats. They have a great important role to play in our existing home market, et cetera, as smart controls. But the complexity of these, balance points, controlling air source heat pumps, et cetera, typically I think are best understood by the manufacturers of the equipment themselves. And so recommendations that I've heard are, if you like this manufacturer's product, match it with their controls for best results in a lot of cases. When the app is released live, Jérémie, will there be user accounts? Will you be able to kind of have your own workspace saved in there? Yeah,
so it's going to be a logged in system. You'll have your own user account. So all your projects will be included in there. And one piece that we didn't go through is you're able to share projects with others. So you're able to track, who are your collaborators on each project, and send that out your collaborators. They get a view only of your project, so
Okay.
they can't change anything. They can only comment on the different steps.
Very nice. Will there be provisions in the future made to include air-to-water heat pumps in the app or hydronic distribution?
Currently, it's not on the plans, but we are exploring, what features are, most sought after, and we'll be looking at, picking the prioritized list and actioning those over the next years.
Great. Well, the questions keep coming in as we answer them. I want to thank everyone for their questions. I think, this many questions coming in is a sign that we've hit on an interesting topic. I like to think, and I appreciate all of the responses, Jason and Jeremy, from both of you for that. Where possible and where appropriate, we will work with the BKC admin team to take the questions we couldn't get to and provide some answers in the follow-up where we can. If you didn't get your question answered live, thank you for understanding. We're trying to stay on schedule with the timing, and we did what we can. You guys were very quick and rapid fire, and I appreciate that. That takes some concentration. So I'll leave it there for today and say a big thank you to both of you for your presentations and for taking us through the live demo. I think that was very helpful to see it in action and very interesting to see how useful this could be to people working in this space. We look forward to the announcement of the actual release date, and we'll follow up with the attendees when we hear about that. So watch this space. I want to take the last few minutes of our time together today just to look ahead. We do have more webinars upcoming in this Critical Canadian Building Science webinar series. The next one is coming mid-August, so hopefully it works around your summer vacation schedules, but mid-August, I'll be hosting a conversation with Alexis Minetti from the Building Knowledge team, who has become our in-house guru on all things carbon, and also Brett Cass from the CHBA. And we're going to be looking at the proposed new tiered carbon emissions regulations in the National Building Code and what this means for Canadian homes. So very much a forward-looking webinar. Very excited to dive into that and look at what's being proposed at the national level related to operational carbon. And that space is very active and evolving all the time. So please join us for that if you can. And last little bit of a plug for us here at Building Knowledge and our Builder Digest, which is a quarterly email publication that we send out completely free of charge. You can sign up today. The link will be posted in the chat for you to sign up to this. Really a space where we like to share industry highlights, articles of notes, building science events that you can attend and get more information on whatever's piqued your interest in the building science space. More webinar announcements and announcements, for example, on when air source heat pump sizing and selection app might be live. All of this type of news you can get in your inbox by signing up to our quarterly Building Knowledge Canada Builder Digest. So I encourage you all to sign up if you aren't already. And with that, a big thank you to Enbridge for helping us bring this webinar series to you all. Again, a big thank you to our presenters today, Jeremy and Jason. It's been a pleasure to hear from you both. And I'll leave everyone with that and hope you all have a great day. We'll see you on the next webinar.
Thanks, everyone.
Thanks, everyone.
Thank you.